So we're given three different functions. F of x equals 2 to the x power, f of x equals 2 times 2 to the x power, and f of x equals 1 half times 2 to the x power. And they all clearly have the same multiplier of 2. Oh, that was a question. It says, what is the multiplier for these? So when we look at them, right, we can see that our multipliers on each case is the number 2, multiplying by 2, multiplying by 2, multiplying by 2. Now we do have different starting values. However, we are all multiplying by 2. This next thing says make an x to f of x table for each of the function using integer values for x that start at -3 and go all the way up to +5. How can you use the tables? How can you use the tables to determine the multiplier? Well, I know what the multiplier is. The multiplier is 2. But let's go ahead and do what they're saying here. So we're going to start at -3 and we're going to go all the way to +5, right? And across the top, we're going to write down each function. The first one was 2 to the x, the next one was 2 times 2 to the x, and the next one was 1 half times 2 to the x. So if I start filling in these values, right, at -3, that's 2 to the -3rd power. I think that's 1/8, right? Because that's it's a reciprocal. It's 1 over 2 to the third. 2 to the third is 8. 1 over 2 to the negative second is going to be 1/4. This is going to be a half. Anything to the 0 power is 1. We've got 2, 4, 8, 16, and then the last one is 32, right? 2 to the 5th power is 32. Now, when I jump over 1, I can see that I think all of these are just going to be twice as big. So instead of 1/8, I'm going to have a fourth, right? And then I'm going to have a half, a 1, a 2, an 8, a 16, a 32, and then finally a 64. And then the next one over, everything's going to be 1 half as big. So instead of being 1/8, it's 1/16, then the 1/8, then the 1/4, then the 1 half. So if I look at this table, right, as I look down the list, as I proceed down from value to value, it's pretty clear that as I go from value to value that these are all double the ones above them, right? And it doesn't matter where I'm at in the table, right? From 4 to 8, that got doubled. From 1 to 2, it got doubled. From 16 to 32, it doubled. From 16 to 32, it doubled. So everywhere I look on this table, every single value below is twice as big as the one above it. So again, I guess that's how I identify the multiplier. I'm looking at when x's are increasing by 1, right? Whatever this ratio, well, and I could say this too, right? The ratio, if I take, for example, a value like 8 and divide it, if I take this 8 and divide it by the one that came before it, I get a value of 2. So I guess I can see the multiplier there as well. All right, so that's one idea. Let's look at part B. Part B says, on the same set of axes, sketch the three functions. Describe the similarities and differences among these graphs. So I'm going to clearly go open this up and do it in Desmos. Let's take a look at that. Okay, so when I have these all opened up in Desmos, right, I can see they're not parallel to each other, right? But it's kind of cool how they start really close and then it looks like they're parallel in a way, but I would caution to use that word because these are clearly not parallel. But there is this thing that's going on where this one had the multiplier of 2. This one had no multiplier in front, it was just a 1, and this one had the multiplier of 1 half. So they're all kind of similar in that they're all increasing, they all roughly have the same shape, but what's different is they're hitting different starting values, right? So that number in front we can see is the a value. So a is 2, a is 1, a is 1 half. All right, let's move on. That's it.